Hi guys, this is lesson 4 for week 3. Today our learning intention is to multiply and divide decimals by powers of 10. Our success criteria is to know the sum is greater when multiplying numbers, to multiply by powers of 10 and divide by powers of 10, which are 10, 100 and 1,000.
So some things to recap before we get started. We need to know what multiplication is, we need to know what division is, and we need to know what powers of 10 are. What does multiplication actually mean? Multiplication is a quicker and simpler way of doing repeated addition. In this example here, rather than having to add 5 plus 5 plus 5 to get an answer of 15, we can simply work out what 3 groups of 5 is equal to, or 3 lots of 5. And we can solve that using multiplication. 3 times 5, which equals 15. The inverse of multiplication is division. A division is dividing or splitting a number into equal parts or groups. You should know what the division sign looks like, and there's an example here. It says if we have 12 cupcakes and 4 friends want to share them, how would you divide the cupcakes? This question's asking us to do 12 divided by 4, which is equal to 3. There are 3 cupcakes in each group. About powers of 10 as meaning 10 multiplied by itself a certain number of times. If I'm talking about 10 to the power of 2, that means 10 times 10, which is equal to 100. If I talk about 10 to the power of 3, that means 10 times 10 times 10, so 3 times, and that is equal to 1,000. The first 3 powers of 10, so 10, 100 and 1,000, are the main ones that we're going to be looking at today. When we're multiplying, we need to remember that when we times numbers together, the product will be bigger than the factors. In this example, 4 and 5 are our factors, and when we multiply them together, we get the product of 20, and 20 is bigger than both 4 and 5. When we divide numbers, we need to remember that the answer, or the quotient, is smaller than the numbers we have divided by. So the dividend and the divisor. In this example here, 40, which is the dividend, is divided by 8, and the answer is 5, which is our quotient. Some more things to remember when we're multiplying and dividing. When we multiply a number by 10, it gets 10 times bigger. For example, 3 times 10 is equal to 30. 30 is 10 times bigger than 3 because we've multiplied it by 10. In the inverse, when we divide a number by 10, it gets 10 times smaller. But divided by 10 is 3. 3 is 10 times smaller than 30. When we multiply a number by 100, it gets 100 times bigger. For example, 7 times 100 is 700. 700 is 100 times bigger than 7. On the flip side, when we divide a number by 100, it gets 100 times smaller. 400 divided by 100 is equal to 4. 4 is 100 times smaller than 400. Finally, when we multiply a number by 1,000, it gets, you guessed it, 1,000 times bigger. 2 times 1,000 is 2,000. 2,000 is 1,000 times bigger than 2. When we divide a number by 1,000, it gets 1,000 times smaller, yes. 8,000 divided by 1,000 is equal to 8. 8 is 1,000 times smaller than 8,000. It's really useful to think of a place value chart when you're multiplying and dividing by powers of 10. If you can draw something like this, then it will be really helpful for you to be able to visualize the numbers getting bigger and smaller depending on whether you're multiplying or dividing. You can see by the key here that when we're multiplying by 10, all the digits in the number would move one space to the left. If there's then a blank space on the place value chart, it would be filled by a placeholder 0. If we're multiplying by 100, the digits all move 2 places to the left. Same again when we're multiplying by 1,000. all the digits move 3 places to the left, and that's representing them getting 1,000 times bigger. On the opposite side, when we're dividing by 10, all the digits would move to the right 1 space. When we're dividing by 100, all the digits would move to the right 2 spaces. And when we're dividing by 1,000, all of the digits would move to the right 3 places. Now I'm going to show you 10 really quick examples about how you can multiply and divide by powers of 10. The first example is with the number 456, which belongs here in our place value chart. If I am timesing that number by 10, then everything is going to move 1 place to the right because there's 1 0, and we're making our number 10 times bigger. And then, because I don't have anything here, I need to put a placeholder 0. I can't just leave it blank. If I'm timesing by 100, each number needs to move another digit to the left, because I'm making our number 10 times bigger again, and 100 times bigger than our original number. 45,600. If I'm timesing by 1,000, and I had my original number 456, the 4 would move 1, 2, 3 place value columns to the left. The 5 would also move 3 place value columns to the left, as would the 6. And then the blank columns would be filled in with zeros. The next example I'm going to show you is with 7.6, and you can try this one at home as well. 7.6 starts here with the 7 in the ones column and 6 tenths represented in the tenths column. If I times that by 10, what do you think is going to happen? Every digit is going to move 1 place value column to the left, which means that the 7 ends up in the tens column, and the 6 moves up into the ones column as it has got 10 times bigger. And that gives us an answer of 76. When I times it by 100, the 7 moves up 2 place value columns to the left from where it started in the ones, so it ends up in the hundreds. The 6 ends up in the tens, and I need a placeholder 0 to represent 0 ones. So 7.6 times 100 is 760. When I times 7.6 by 1,000, the 7 is going to move 3 place value columns to the left from where it started in the ones to the thousands. The 6 is going to move 3 place value columns as well to the hundreds, and then I'll use 2 placeholder zeros to represent 7,600. The next number I'm going to multiply by powers of 10 is 54.2. 54.2 starts here with 5 tens, 4 ones and 2 tenths. If I times it by 10, there's 1 0, so each digit moves 1 place value column to the left. And the number is now 10 times bigger. If I times it by 100, each place value column needs to move 2 columns to the left from its original starting point. So the 5 was originally here, and it ends up in the thousands. The 4 was originally in the ones, it moves 2 place value columns to the left to the hundreds, and the tenths moves 2 to the left to become tens, and then I use a placeholder 0. If I times by 1,000, I can move everything once more up because it's already moved to 2 places up. Oh, and this time I need 2 placeholder zeros to make 54,200. My final example is with the number 72.43, which starts here with 7 tens, 2 ones, 4 tenths and 3 hundredths. If I times it by 10, each digit needs to move 1 place value column to the left, as they are getting 10 times bigger, which gives me an answer of 724.3. If I want to times it by 100, there are 2 zeros, so I need to move each digit 2 place value columns to the left from their original starting point. 7 started here in the tens, and then to move 2 places up, it ends up here in the thousands. 2 ends up in the hundreds, and 3 ends up in the tens. 4 in the tens and 3 in the ones to make 7,243. Finally, if I'm timesing by 1,000, everything needs to move 3 place value columns to the left, and we have a number which is 1,000 times bigger than what we started with, 72,430. Alright, now I'm going to show you how to divide numbers by powers of 10. My first example is going to be with the number 36, and I'm going to divide it by 10 first of all. When we're dividing by 10, we do the opposite as to what we did with multiplication. We take our digits 1 place value column to the right. 36 divided by 10 becomes 3.6. Our number has become 10 times smaller. If I was to divide that number that we started with, 36, by 100, I'd need to move the digits 2 place value columns from where they started. So 3 tens would become 3 tenths. 6 ones would become 6 hundredths. And I'd use a 0 here to represent 0.36, which is 100 times smaller than 36. If I was to divide it by 1,000, then the digits would need to move 3 place value columns to the right from when they originally started. 3 tens would become 3 hundredths. 6 ones would become 6 thousandths, and I'd need to use placeholder zeros to represent 0.036. The next example I'm going to show you is with 6,042. First of all, I'm going to divide it by 10, which means that each digit moves 1 place value column to the right. My number has become 10 times smaller, and it is now 604.2. If I were to divide that original number by 100, I'd need to move each digit 2 place value columns to the right. I've already gone 1, so I'm going to move them 1 more to become a number that is 100 times smaller than it was originally and now represents 60.42. If I was to divide that number by 1,000, the original one, I would need to move it another place value column to the right, so I've done 3 altogether now. My number has become 1,000 times smaller and is now 6.042. The next example I'm going to show you is with 65.2. First of all, I'm going to divide it by 10, which means that I need to move each digit 1 place value column to the right, as it becomes 10 times smaller. My number is now 6.52. If I were to divide it by 100, I'd need to move the digits 2 place value columns to the right from where they originally started. So 1, 2, 1, 2, 1, 2. And now my number is 0.652 and is 100 times smaller than where it started. If I was to divide it by 1,000, then I'd need to move them 1 more place value column over for a total of 3 from their original positions. And now that number is 0.0652. My next example is going to be with the number 91.4. First of all, I'm going to divide it by 10, which means that each number, or each digit, moves 1 place value column to the right to equal 9.14, 10 times smaller than 91.4. Next, I'm going to divide it by 100, which means that each digit moves 2 place value columns to the right from their original location. 1, 2, 1, 2, and 1, 2. My number is now 0.914 and is 100 times smaller than when it started. To divide by 1,000, I'm going to move the digits 1 more place value column to the right to become 1,000 times smaller than the original number, which is 0.0914.